Welcome to the AMATIC 2015 webinar series, Teaching Students with Real-World Application with Stefan Baratto. And this presentation is sponsored by the Mathematics for AAS Programs Committee of AMATIC. And AMATIC is the American Mathematical Association of Two-Year Colleges, and our core value is building expertise and exhibiting leadership in the teaching and learning of mathematics, enhancing personal growth, and improving teaching methods and effectiveness is a personally initiated lifelong responsibility. And for more information, please visit our website at amatic.org. And please note that the views expressed by the presenter are not necessarily the views of AMATIC, and any commercial products mentioned by presenters are not endorsed by AMATIC. And WebAssign is proud to support the AMATIC webinar series. And now we're going to switch to the presenter slides, which I actually have already up. And before I turn it over to Stefan, let me actually introduce him. So Stefan Baratto is a faculty member in mathematics at Clackamas Community College in Oregon, and Stefan is a 25-year-old, maybe you want to be 25-year-old again, but 25-year veteran with experiences ranging from middle schools through universities in Oregon, Maine, Missouri, and New York, and he is the Ormatic president, a former three-term AMATIC Northwest vice president, and has presented at numerous conferences. And Stefan is the lead author of the Hutchinson series of mathematics, a series of developmental math textbooks from McGraw-Hill Education. And again, let's turn it over to the man who is a 25-year-old at heart, and have a great presentation.
Thank you, John. I hope everyone can hear me. There is a button at top to allow you to change or to adjust your volume. This is a little long, so if we don't get through it all, I can easily email anyone the PowerPoint. Also, we have a Word and PDF document of the actual applications which are embedded in this PowerPoint right now. Nice to see we've got a great geographic distribution, although it's kind of weird talking and not having you be able to talk back in a webinar. I haven't really done that before, so this is sort of new to me. Usually I've done them by phone, and so everybody could talk. So let's see, I'm at Clackamas Community College, which is right outside of Portland, Oregon. I live in Portland, though I've moved around a bunch in my life. So let's see where we are today. So as most community college instructors, somewhere in the area of 2/3, 3/4 of my load is developmental. And we have a number of goals in developmental mathematics, as far as I know. I mean, we do want to teach them skills, of course, adding decimals, multiplying, dividing, the whole bit. And problem solving as a general, how to approach different problems, how to do it without fear, even when it's new, because that's what they're going to need. Critical thinking is interesting. I've got some colleagues who talk about critical thinking as if it is a skill itself, and I've never really thought of it like that. I think of it more like an umbrella term, sort of like wisdom. Hopefully they will become better at that. They learn to think critically about each new topic and each new idea. There's also a couple of others. Technical communication, we'll talk about a bunch. That, for me, is actually really most of the point of developmental maths. There are other goals, for example, helping them with their barriers and their anxieties and the like, right? And we all face this, I assume. So are there any goals, major goals that I've missed? Feel free to throw it out in the chat room. In this situation, I might actually call on people if we were talking, but that's tougher when we're not. So if somebody wants to throw out an extra goal, I have a few of these slides, and I'm not sure how well they'll work with the typing. So we'll see and sort of learn as we go with this one. All right. Some of the ways I meet those goals. One of the things I've been doing the last few years is doing my teaching through applications rather than do it the way I used to do it, and we'll talk about that too. I find that it helps them to learn their skills. They become more comfortable reading and solving problems, and applications really help them learn to think critically about content. It's not completely without its problems. The big one for us, especially at the lower levels of developmental math, the pre-algebra type levels, many of those students are simultaneously in need of developmental reading courses. That makes it difficult. On the other hand, if they find the applications relevant, that makes it a little easier. But I mean, everything has costs and benefits, right? I mean, teaching in the abstract math is something we're not good at. So, as an example, I do this the first day of class. You know, we do the syllabus and admin stuff, and we do a prerequisite sort of thing to make sure that they know what they need to know for the course. And then in my developmental courses, a lot of them I'll do what's a Wasson selection tasks activity. Wasson was a psych researcher in the 60s. He did not do this for a math class, obviously, but what he created, John, are you seeing a Word document there?
Oh, I'm not. Is there supposed to be a Word document?
Yeah, there's docs embedded.
Oh, I guess Oh. Okay, let me try to get them on the screen for you then.
Okay, thank you.
Sometimes it doesn't embed, but I can get them up here in a second.
Okay, so I'll explain the Wasson selection tasks activity. Basically, Wasson paired two activities or two tasks which required students to use logic. One of them completely abstract, and one exactly the same logic, but much more concrete. And he was trying to show that humans evolved to do logic in the concrete because we needed that, but not in the abstract because we kind of didn't. And what his experiments basically showed that when doing abstract logic, maybe one third of the people who did that would get it right. When doing it in the concrete, as much as 90% would get it right. And if you Google like Wasson selection tasks, you'll come up with dozens and dozens of pairings. Some people caught on to this and just dug it and created new ones. Hopefully, we'll see these in a second. Yeah, there we go. Okay, so the first one that we're looking at, this was the abstract one. It's a pure if-then loop. If you've got four cards sitting on a table, one side has a number, the other side has a letter, and you have an if-then rule. If if there's a vowel on the letter side of the card, then there must be an even number on the other side. And when I have my students do this, maybe a third of them get all four right, maybe even less. The E and the 9 in particular give them trouble. Um, do we have the next one, John? Hmm. Uh, so the next one is a much more concrete version of this, but it's exactly the same logically, and my students tend to, being students, they tend to know this. Basically, anyone under 21 is not allowed to be served alcohol in public. And so you have a situation that is logically equivalent to the previous one, but in it, every time maybe all but one student in the class get all four of these right, and that student tends to be overthinking or something like that. Um, and basically, Wasson was absolutely right that we can do stuff in the relevance when it's relevant, but not. So, can I control these? We can do stuff when it's relevant, but not in the abstract so well. Um, yeah, can we move these? Thank you. A couple of things the Wasson task does is it teaches them, sorry about that, little technical glitches here. Teaches them my expectations, they that I want them to read carefully and think about problems. It's short, it's a first day. We've already done some math. They're a little tired, um, and so it's just a fun activity to do on the first day. But really, what we want to get at is how I need to be relevant with the mathematics, especially for the millennial generation. So there's a problem there too, finding applications that they care about, but are also within the abilities of a developmental math student, not always the easiest thing. Um, Looking at what we're trying to get at, so the scan skills, scans was during the Clinton era, he directed the Secretary of Labor to survey business and industry and find out what B&I thinks college students need that they're not graduating with, basically. What are they missing? What holes are happening in their education? Now, of those skills, some of them were blatant, like they should be able to add, they should be able to write a sentence. Some a little more intangible, such as technical communication skills. Of the many intangibles, the soft skills, so to speak, some of them are really well learned in a math class. Those are the skills that, like, we don't have a class for. We just think that somewhere over their college experience, they'll get this. And so things like technical communication are really learned well in a math class, I think. So that's the ability to read, to think critically, to understand technical writing, and then communicate technical information back, even something like an instruction manual so you can actually put the desk together or put the bookshelf together. It is really important. It can also be dull. I mean, think about reading a calculator manual or a healthcare benefits type package, right? We got 3 more slides, John, coming up. So one of the things I do is when we do percent problems, we do this before we do any algebra, so we're not doing it from an algebraic perspective. And just reading the percent problems. I use base, rate, and amount. So this is the base in the problem, the starting point. This is the amount. It's a piece of the base. The rate is what sized portion of the piece. And identifying that in both abstracter problems and in more concrete terms. So if we can get, I guess, yeah, these should be coming up in a second. Right? And being able to sort of pull out the math and reading the math from a problem is really important for our students, obviously. So, John, can I share my screen with them and do it that way instead?
Yes, but this should work in about 5 seconds or so.
Well, because we got 2 more that follow it immediately.
Oh, yes. Well, what I'm going to do is switch you to this PDF file
Ah,
so if you just hit the down arrow, it should take you to the
bingo.
slide that,
There we go. Can
is
everyone,
that better?
much? Is everyone able to see this?
Okay.
So, as I was saying, here we go. So this works now. Hopefully the glitches are worked out. Sorry about that, everyone. Um, so as if we look at example 2, which is this top of the second page here, 60% of the 80 students who took Math 50 last term are now working. How many are working, right? After seeing how to do it when we have everything, we're now seeing how to do it when there's an unknown. So they learn to identify, pull out the rate, pull out the base, pull out the unknown, right? Figure out what it is that they need. But even better would be a more concrete problem that uses stuff they know. So one thing I like is sales tax. Actually, in Oregon, we don't have sales tax, but most of the places I've lived in do. So if you're in a state with 7.25% sales tax, they buy an iPod, it's listed for $299. How much will it cost after the sales tax? One of the beauties of problems like this is they really add some extra deep critical thinking type skills, right? I mean, so are they computing the tax or the price after the tax is added? So usually I try to have them do the latter, basically, 107.25%. We teach them, oh, right, it's money, you round to two decimal places, right? There we go. It's money, we round to two decimal places, and you can discuss if you use 7.25% rather than 107, you're computing the tax, but you need to add that back afterwards. It's one of the beauties of these kinds of problems, percent problems, is a percent problem more than anything else really forces them to go back and see if they're actually answering the question, right? Because there are many legitimate questions. How much the tax was is legitimate as a business owner because I'd have to fill out a form with it. How much the selling price is important because I have to know how much money to take, right? So both of those are legitimate questions. Um, and many of them own iPods, they own phones, they pay sales taxes, so they at least can relate to the problem much better than, say, the previous problems. Even this one, um, they don't relate to it as well as this. This requires more work and effort on their part, but it's also more relevant, which makes it more likely they're willing to put in that work or effort. Another skill that I find working with applications rather than the abstract is distributing a negative sign. So I think this skill actually gets learned much better when teaching it in context. So we start off with, early in the term, I deal with revenue, profit, and cost models. So here's one of the examples I've used in class. You've got a bookstore. Their wholesale price for a book is $6.27. They sell the book for $14.95, and the weekly fixed costs associated with selling the book is $2.85. So they've learned now, this is beginning algebra, they've learned to write an expression for the revenue, right? The amount that you're charging times the number you sell, and as an example, evaluate that expression for 75 books, which they've learned how to do. They can write an expression for the cost of selling the book each week, and they can evaluate that for, say, the same number of books, right? And if I ask them to find a profit on selling on 75 copies, most of them will just take those two numbers and subtract. But what we really want to get at is the generalization. And it's right here that they really run into the problem, as I'm assuming we all know, right? That minus sign right there. I mean, distributing that negative. When I do this in the abstract, that negative never gets distributed. On the other hand, when we do this in context, they can see that, oh, that's a cost. It has no business being added to the profit, right? That I've got to sell enough books to make up for that, right? And so while they can do the subtraction once and get $366, what we really want is them to generalize it so that they have a function which they can plug in multiple different numbers of book copies, right? And so that's sort of what I'm doing now, just as a quick intro to it. How that differs from the past. I mean, I learned math class the same as most of us, I guess, right? Introduce a topic with an application, show how the application requires them to learn math that they don't know yet, and then you move on to the math content in the abstract. So here's the reality of that. They know that's what's happening. They know that's coming. They're just waiting for that to happen. As soon as I move into the abstract, eyes glaze over. They look out windows. Nowadays, they surreptitiously look down at their phones, right? But whatever they're doing, they're not really engaged anymore. And you do the standard examples. Students do examples. Hopefully, at the end of the class, I can get to the application and complete it. And if there's time in that day, maybe they even get to practice with an application, right? But really, not the greatest way to teach. I mean, there's that we slip into the abstract and they go blank. So, if anyone has any ideas and wants to type how you help your students maintain if you do that sort of model and it works for you, tell us how, right? I mean, because that model, I lose them somewhere in there. Now, so how that changes for what I do today, and this I really learned. I teach tech math, a lot of the tech math courses, and so um, that's a much more applications-based course anyway, much less abstract. And what I found was successful there when I flipped it into my algebra courses, I found, and my pre-algebra courses, I found that to be more successful than what I had been doing, and it changed how I teach. So I introduced my students to your basic models, like I said, of revenue, cost, and profit. And they're more interested when you have that, you know. And as we're going through this application, which they're going to run out of math for and they're going to need to learn math, I could see them. They're at the edge of their seats. They're waiting for me to switch to the abstract. They want to glaze over in math class. They want to go to their phones or look out the window or whatever. And I don't. That's it. I no longer switch to the abstract until afterwards, right? So, um, yeah, we've already talked this. I mean, I no longer switch to the abstract until afterwards. They're allowed to do that, find the profit by doing a subtraction one time, but after that, I want them to get at, let's subtract the entire cost from the revenue, right? All of it, including the fixed costs. One of the benefits I found with this is that they get a better understanding of grouping symbols. I mean, most students, they see parentheses and grouping symbols as something math teachers use just to make their life miserable, right? I mean, instead of going left to right, all of a sudden, or order of operations straight without the grouping symbols, all of a sudden they need to do these things like distribution, and it's just miserable. But with this approach, they actually gain an understanding of why I need to do that. That I would need to subtract the costs, the fixed costs as well, from my revenue before I call it profit. Right? After that, then I can have them work together, learning, doing it in the abstract, and they're better able to master that now, because I mean they do need to be able to do it in sort of more abstract cases, but they're more able to do it because they now see the relevance, because they now see why they have to. The first time I did this in an algebra class, on the final exams, more students got that right than I could ever remember. It was awesome, and each term I teach this, that still happens, right? And it's thrilling. It's awesome. But I shouldn't be surprised by this. This is exactly what Watson was talking about. So, using applications in the classroom, finding them, how to make them work, what kinds of applications should we have? I do want my students to be interested in them, but I need more than that. Their interest sort of helps prevent the, oh, I hate math, I hate word problems, which I've never quite gotten. I mean, students who actually read a lot hate word problems. I would think that's the thing they like the most. But, I mean, who am I kidding? That's not a reality. So, like we did with that percent example in the beginning, helping them sort of find the math and the word problems, separate it into the parts as they need to. That's sort of the basic challenge, especially if reading is not their strength. But finding the applications, relevant applications, that does tend to motivate them more. Some of the things that help, topics. So when a topic is especially difficult, this really also sort of gets them more involved, gets them more engaged. So one of the things my students always have trouble with, we introduce functions in developmental algebra, the notation, domain, range, evaluation, solving, that kind of thing. And one of the ideas they really find difficult is nothing can go to more than one place, right? Everything goes somewhere, nothing goes to more than one place. Basically, no element in the domain can be paired with more than one element in the range, but multiple domain elements can be associated with the same range element. That's one of the topics they find difficult. They don't like that idea. But when trying to teach them that the math we do is because this is what's useful, and that helps. So the application I've now started using for this involves grades and spreadsheets. When they see how their grades are calculated, spreadsheets working with functions gives them a real-life example of a function where I want two different inputs to go to the same output. And just to boot, I've got a natural function whose range is not a set of numbers. So there we go. Basically, I do a points game, and then what percentage of the total available points have they gotten, writing that as a whole number 0 through 100. I then have an if-then loop in Excel. If 90 or above, then A, else if 80 or above, then B, etc. And so they understand this, right? And so the first two questions I might ask is, what grade would two students get? And even though they have different raw scores, a 92 or a 96, I do want them both to get an A, right? So I do want my function to take two different inputs and give them the same output, right? So that's the starting point of how I do my grading. I may then bump up a student's grade, but they understand this as at least the starting point. On the other hand, one of the other things we want is that if two students have the same, I can't really move the arrow well. If two students have the same grade, such as this 86 and this 86, I want it to always spit out the same letter grade. I want both those students to get a B, right? At least initially from the computer. If one of those students gets a C and one of those students gets a B, one of them is going to be really annoyed. So they understand that too, that nothing goes to more than one place. 86 will always spit out a B, though both 92 and 96 I'd want to have spit out an A. Right? And then, we go through more function stuff. Are grades a function of scores, or scores a function of grades, right? Yes, no. Asking them to justify based on what they have in the background as the definition. Finding domain and range. So some ways of choosing applications. First, modern. They need to be able to see, believe, prices need to be up to date, things that might be in their careers or what they want as their careers, brands that they want, right? And maybe throw in a little surprises as well. So one of the ways I do this when we teach rates, gas prices, traveling, mileage, fuel efficiency, right? As long as gas prices are in the news, this one's a relevant topic for most of them. But throw a little something extra at it. So according to Boeing's website, basically it holds nearly 60,000, a 747 takes nearly 60,000 gallons of avgas, and it can travel over 8,000 miles on that, right? So find the fuel efficiency of the plane. They have a lot of trouble believing this one. I mean, it gets a tiny fraction of a mile for each gallon of avgas. They want to flip that fraction. And so again, getting at how do I teach them to think critically about stuff, that they shouldn't flip that fraction, that yes, a plane is a large object and it doesn't get far on a single gallon of gas. But then let's now expand this. A plane is also not just driving one person, right? A 747 might be holding 150 or more people. So if I think about that and add up the miles flown for each of those people, I get 1,000,003 passenger miles. And so if I compare that, what I get is about 23 passenger miles per gallon, which is not an unreasonable fuel efficiency rate. And, you can compare it, say, to a car like a Ford Explorer. At least this was the gas mileage, the fuel efficiency of a Ford Explorer a couple of years ago. And then what is it when they flip the fraction? Because a lot of them in Part A wanted to flip that fraction. And so again, let's think deeply about this. Miles per single gallon, or gallons of fuel for each mile, right? Nearly 7 gallons just to get 1 mile. There are some really good places or sites to find applications and data. I love BLS. BLS is awesome. If you're a data geek, they're fabulous. But for many of my students, that does have some relevance because BLS does have like prices of apples and milk over time. So if you're trying to do regression analysis, it's a fabulous site for that. But Amazon and Google have most popular lists. Toy stores and Home Depots type places have most popular lists. Zillow is a good one for home prices, especially like when home prices are in the news, or if you have students who are older than the traditional age student, and so might own houses. Also, brands that are popular or upscale or trendy. Not necessarily stuff that they would settle for, but the stuff that they would want. News, events, elections like gas prices, like housing prices, are also a fabulous spot. So one of the ones, this one came from, I had a discussion with my father. My father has become more conservative as he's gotten older and sort of he had just they got hit by Sandy. They had a house in Rockaway Beach, and so he had just finished cleaning the bluefish out of his basement. And we get into this discussion, and he says, "Oh yeah, despite Sandy, the number of severe Atlantic hurricanes have decreased, and had decreased recently at that point in time." And so, because of that discussion, I went searching and found basically this data, which yes, somewhere between in the second half of the aughts, there were fewer of these serious, severe storms than there were in the first half of the aughts. But as you can see, I'm at a completely new baseline, right? We went from for over a 5 year period averaging about one a year to two or more a year. And I kind of had to use larger than 1 year because the annual variation was larger than I needed to be. But we could also do decades, 9, 16, 25. But I like the 5 because it does show that decrease from the first half of the aughts to the second half of the aughts, but also shows us at a completely new baseline. And I thought that was really a fabulous graphic. He even believed it for a little bit, my father. And you get at the normal questions we ask: what kind of increase was there? When were the largest increases? Those sorts of things. But you're now dealing with it. If I was teaching on the East Coast, this would be big as an example, an application. Some other ways of approaching it. What do they like? My students like chocolate. So when working with tables and percentages, you've got a couple of little things here in addition. This is where chocolate comes from. And working with tables where you're dealing with millions of dollars or millions of pounds at your unit as your unit instead of just one allows you to add to the experience. And we keep going with the normal stuff. But one of the things that allows me to do once I've played with this table with chocolate, right? One of the things I can then do is build on an application. So one of the nice things about applications is, yes, the first time you go through them, they need to spend a few minutes grokking what that application is. Okay, so we're dealing with chocolate production, percentages, cost or revenue, but I can then a couple of days later or a week later, take that same application. And now if they found the application relevant, if they liked the application, you don't need to completely introduce it as a new application. They'll actually recall enough of it that you can then build on it, right? So, we go from here's a table with percentages to here's a pie chart, right? This is how we build the pie chart. The places that produced more chocolate have bigger wedges. The ones with smaller producing nations had smaller wedges, that sort of thing. So again, building on the application, taking an application and reusing it in a slightly different context is very helpful for them, I think. Business and finance. Unfortunately, many of our weaker students see themselves as business majors, which from a societal point of view, I think is a bit problematic, but we all know this. Other resources, there's some fabulous resources on your campus. Just your campus data alone, if you can use some of that, scrub it clean, they at least see that on a day-to-day basis. One of the things I learned in the tech math, while teaching the tech math, is, we sometimes see departments as islands. And math, we're a service department. We get 2, 3 majors a year in a campus that's got a head count of over 30,000, 35,000. So we really are servicing these other disciplines. The faculty in those disciplines, they know what their students need. They know the employers that'll hire them, and they really want to help you. They know no one is dropping college because they don't like plant identification. walking around campus and identifying plants. They drop, they leave because of their math and English classes most of the time, or because of real life, money, family, those sorts of things. To the faculty in these other disciplines, they're the ones who have to go to recruit students, right? I don't recruit students. Heck, the college wants the math department kept quiet when they're doing recruitment. Oh, yeah, yeah, we'll talk about math when you get here, but first we got to get you in the door. We're not going to scare you off ahead of time. And so the faculty in these other disciplines who rely on student recruitment for their budgets really want to help us succeed with their students and know a lot of applications that work for them. I mean, when you think about things like mixture problems, for example, I mean, the standard sort of problems, unless they're pickling, they don't care about acid solutions. Home brewing, they might nowadays care about alcohol solutions, but it's not. Thank you, Crystal. It's not that common. If they want to know how many nickels and dimes are in their pocket, they'll just count them, right? They're not going to sit there and do a mixture problem for this. On the other hand, they do see themselves in the health sciences field. They do see themselves as owning a business one day, or they hope to. So some examples of this, out here, I'm in the Pacific Northwest, coffee's big, right? We're big on our coffee. And so they can see, we have these little coffee shacks that dot everywhere. People drive through, pick up their coffee on the way to work in the morning or on the way to class or whatever. And a lot of places do sort of a mixture of beans, right? Those places have really slim profit margins. I mean, really slim. And if they screw this up, they go out of business, right? That's why they're under new ownership every month. So my students can get into this one. These are a couple of in-depth, tougher problems, but at the same time, often they'll engage the students much better than the fake problems. This person's age and that person's age, right? I mean, these are the kinds of problems that at least have the hope to engage them. As far as toys and products and the like, again, if you're a parent, you know what's popular nowadays. If you don't have young kids, some of your students do. Ask them. I mean, they'll tell you. Or again, Google or Amazon's most popular list. Likewise, Fendi handbags, all-clad cookware, kicker amplifiers. My students want those products or know that those are upscale type products, and it actually keeps them somewhat interested, believe it or not. So yeah, another one who's worked with these. If you haven't worked with faculty in other departments, they're really, really helpful. They really want to help you succeed. It's really a worthwhile endeavor. Yeah, I guess for 20 of us, answering these questions by typing, I guess this model for a webinar, I'm not really sure how to do this participatory. So I'm going to move on with this and maybe talk to John before I do another one. The other problem we have with doing this method is instructors. Most of us were raised the way I used to teach math. I mean, it was a very teacher-oriented, very abstract math-oriented sort of classroom. The other problem for us is that I got way too much stuff to do in a single term. It's tough to get it all, and it's easy to tell myself, well, each application takes a lot more time than a single abstract example. How can I possibly fit that into my class time? My answer to that is no, it's the abstract that's less important. Applications, that's not cutting into the class time. That's the game. That's why we're here. And it really helps them develop the skills and the abilities that I think are really important. One of the benefits is they're more attentive if they're interested in what you're doing. And that means they're going to learn more, they're going to retain more, they're going to be more engaged, basically. Even my best students, my true A students, they don't learn everything we do. They walk out of the class remembering, my best students remember most of it. So the question of maybe we do want to reduce some of the content and help them learn what we do better, because in the end, I think they'll learn the same amount, right? If I have less content, but more depth and better learning with it, through things like teaching with applications, I think they'll learn just as much, even if we skip some content. Tough because everybody's got their favorite topics, but that's what I think. One of the other things I find that's very, thank you, Pat, that's very useful is modeling. So I used to, we would, even when we did an application, I would do that, we do this application, and the answer would be 47 students, and I'd write 47 on the board. And no, I mean, if I want them to go back and make sure they're answering the question, to reread the application at the end, and to write their answer to describe what it is they found and what their conclusion is, I need to model it. It's not something I particularly enjoy doing. I mean, writing full sentences on the board, I'm teaching math, not English, but I do find that that helps. And the more I do that in class, the more they do that on their exams, on their homeworks, on anything else they're submitting. And I mean, what occurred to me a few years ago is I assume they need help with the math. I assume that we're teaching them this. They don't know this. They're learning this. But for some reason, I had this weird assumption that, but once they get that 47, they could describe that in a sentence. And I quickly found out that that was just not the case. And yet at that time, I was modeling, the math, but not modeling, describing it. And it's just weird that it didn't occur to me when I was younger that that's necessary for us to model. Nice, Stephanie. Definitely. Um, they also need practice, right? So I like them working in groups. I don't force it, but I strongly recommend that they work with people around them, especially with the applications, helping each other read them, see what it is. If somebody's got weaker reading skills, that helps them a little bit get through whatever might be difficult there. Um, and if they're not, I mean, basically, I went to a dendrite theory seminar at Amatic one year. Um, Somebody had just come back from this, and basically they said, students watching us do math problems learn to watch us do math problems. Very useful skill in the classroom, utterly worthless outside of the classroom. And so anytime you do examples in the class, it's got to be followed up with them working. Them, remove the teacher from the center and have the students getting to work on their own, because that's how they learn to do math, is by doing math. And a lot of us need to be taught this, right? It's not as natural for us. Um, it's not as natural for us. Uh, it helps, especially if your handwriting isn't so fabulous, which mine isn't. Everything is on a computer, on a projector screen, document camera. If your classroom is not equipped as such, even handouts or an overhead, whatever, some way of making it easy for students to read, to get at. They don't have to wait for you to write everything, where they can then buzz out, glaze over, look at their phones, and then give them time. Right? It's so tempting to interrupt them when they're 2/3 of the way through, when they're struggling with it, and helping them before they've. I mean, you need them to run into that wall first. This way, they can understand that wall better. And then, those who still, at the end, when enough of them have gotten through it, then work it out with them. But even that, questions. Where should I go with this? How do we start this? Right? And you can design these problems so that there are true teachable moments, which in the abstract, I don't think I ever get to. Right? As an example, so back to this bookstore again, building off of this example. So we've got the same data that we had when we first brought it up. So if I say you need at least $750 in revenue, how many do you have to sell? Right? And so if you do that, now this is a solve, not evaluate, but I get something in the area of just over 50, right? 50.17. But if I need at least 750 in revenue, that's a round up, right? Because 50 will not get me that revenue. Similarly, if say I cost can exceed 1200, okay, for that number I get 145.9, but that means 145, not 146. At 146, you've exceeded 1200. Maybe not by much, but if it cannot exceed, right? And so that now gets into, right, I round normally, but when do I need to apply context to what I'm doing? And like I said, when I was working in the abstract, there were really teachable moments like that and real good critical thinking, rare, right? But now that happens most every class session that I do this. So, cool, good timing because we'll have the Q&A. Basically, the applications that makes it feel important to them. They can relate to them. Gives you the ability to build one on the other. This type of problem on this type of problem on the same set of data. Personally, enthusiasm is big. I teach with adrenaline and energy, and that helps me. When I used to chair and would see student evals for our part-time faculty, um, the more energetic instructors definitely saw better evals. And I think that group work, which we could expand on in a lot of ways, gives the class community feel, spirit, helps them work with each other, helps them teach each other. Even if somebody has to miss a day or gets frustrated with something, somebody to talk to who they can relate to. So that's what I brought to you today. Thank you very much. My email is here, SBARATTO at Clackamas. I'll leave this up as we chat. Um, yeah, so I guess it's question and answer time. Do you have any intro to this, John?
All right, well, I'll leave the slides up for a few more minutes in case anyone wants to go back to any of the slides, but I did put the link or to download the handout on the screen. I'm going to put the Word document there as well, so everyone should be able to click on the file name and then hit download files and then get the handout.
Okay, thank you. Yes, all of the Word document embedded in here, the white background, there is a file in both Word and PDF with all of those, which John is making available to, and this PowerPoint should be available as well. If for some reason you have trouble with any of that, if you send me an email, I will send you attachments. I will send you PDF or Word of just the applications or this PowerPoint. Um, the applications are sort of formatted a little differently in the PowerPoint because the pages are small, but it's exactly the same stuff. You're welcome, Jeff. Any questions, any talk, any discussion? You're welcome. And so, yeah, I see that John has now uploaded all three of them in a format that makes it pull downable, I think. Exponent rules. There's a couple of topics that I have to admit are tougher to go with the applications. Um, Factoring still feels fake to me in applications. I mean, gee, you know the area and only one side of a rectangle, those sorts of things. I can get at the factoring when we're playing with quadratics, but I usually need a little more. Basically, they kind of have to know how to factor before we get there a little bit, but we can work with it. Will do, Pat, for sure. On the other hand, exponents usually it's on multiple days is when you'll those are two of the tough ones. Basically, what we consider I'm in quarters, so our second course, there's this stretch where this is definitely tougher to do with. I do my best, but it's exceptionally strong. If you do email me, Jennifer, I do have some of those, and I could pull up the sheets that I use in class and email them to you. Because there are some applications there, just not a ton. Um, Often with the exponent rules, scientific notation is a good one, I find. There's an example I use. So this is how much water is in the United States, fresh water. This is how many people there are in the United States, both in scientific notation, how much water is there per person. And the numbers scare them, right? Because we're talking about, 3 we're talking about millions of people and lots of gallons of water, but it gives you the opportunity to do something like, let's now make this easier. Let's say there were 20 gallons of water and 4 people. How would you do that? Right? And they know to divide and get 5 gallons per person. Well, one of the things I like to say in class is that if it works for nice numbers, it works for ugly numbers, right? The whole point to math is my methods don't change just because um, everything got ugly. I'm going to still use the same methods. And so if I'm saying 20 gallons of water for people and I divide, then 3.1 times 10 to the 6th or whatever times 10 to the 7th divided by however many gallons of water it is, I would still do the division there. And now all of a sudden I'm dealing with the exponent rules. I'm dealing with, so 10 to the 7th over 10 to the 4th is 10 to the 7 minus 4, that kind of thing. So yeah, Jennifer, if you email me that request, I will happily send you what I do use in class. But and there's a few of them that I think are good, but not all of them. That, like I
Stefan, can
said, that's a
you
tougher
put
topic.
your email address in the chat room in case somebody missed it on the slide?
Sure, absolutely.
And well, you all can go ahead and continue to point out any questions, but let me wrap it up here for anyone who needs to get going here. So thanks again to Stefan, and if you all could thank him in the chat room, that would be great. It was a wonderful presentation full of a lot of applications and information that I'm sure all of us can take back and use ideas from right away. And so thanks for participating in today's AMATIC webinar, and if you'd like to support future AMATIC webinars, please consider becoming a member of AMATIC at bit.ly/join-AMATIC. And please remember to like us on Facebook at facebook.com/amatic. And then recordings of past AMATIC webinars can be found at bit.ly/amatic-webinars. And it typically takes us 1 to 2 weeks to produce and upload webinars to this archive. And I will send you an email alert when that is done, along with links to all the files if you weren't able to download them today. And if you could please take 2 minutes to evaluate the webinar content and the presenter today at bit.ly/amatic31. And if you need email confirmation of your participation in today's webinar, please fill in the optional section at the end of the evaluation, and I'll make sure that you get a certificate. And again, that's bit.ly/amatic31. Just click on the link right on your screen, or you can type it in. It is a clickable link, and any feedback that we get is greatly appreciated. So again, if there are any questions, I'm sure Stefan won't mind staying a few more minutes, and let's thank him again. Great webinar today. And again, sorry about the technical difficulties, but I'm thinking that it all got straightened out.
Thank you very much, John. Yeah, it all worked. There's always a little glitch here and there, right? We used to teach, I guess, with chalk and slate, so we can make anything work. So I appreciate your help very much. Thank you. The the function one with grades is one that I came up with recently. A couple of terms ago, I think I came across this and said, that works. I was at my affiliates conference not too long ago, and Mike Price at the University of Oregon came up with an interesting one for functions as well and domains and ranges. He thinks of it like a microwave. And so the domain is the stuff you can put into the microwave, and what's not in the domain is stuff that would be bad to put into a microwave. And the range is the outputs, right? Oh, you got this heated through lasagna now. And I thought that was a cute little example of functions and domains and ranges as well. I'm working on one more app that I've been doing. So I swim laps, and there's about 72 lengths to a mile. And swimming, one of the problems is you can't put on headphones, that kind of thing. I think that'd be a great invention. People would make millions if they could figure that out well. But I do fractions as I swim. Oh, I'm now at a quarter of a mile. Oh, 2 more lengths is a 36th of a mile. And I don't know, being a geek, I do fractions on how much of a mile I've gotten, how much of 2 miles I've gotten. And I'm thinking about trying to find a way of putting that into an applications for the students. I don't know if they'll like it or not, but at least I enjoy that one. So that's another one I've been thinking. I mean, all around you there are applications for your students. I do too, John. Um, for the newer students at the math, the lower levels, I try to get them to think about like doubling. Start with a number and double that mentally while they're driving without getting too distracted. Don't cause an accident. But it gets them. I hope if they do that, I think it would build their sort of number sense. Wow, so they now have a waterproof iPod, huh? Um, I got to get one. I didn't know that had finally been invented. So does anyone have anything else? So again, thank you very much. It's been an absolute pleasure working with you all today, and I'll wait for somebody's typing, but it's been an absolute pleasure. I enjoyed this very much, and I'm glad to do this morning. Thank you.
All right, well, thanks again. I'm going to end the recording now.